Hey everyone, it's Mrs. Smith, and this video is to go along with Unit 6, Lesson 3. That begins on page 325 and goes to 328 of our math book. So you can pause this now, get your page out, get your pencil, and then when you're ready to start, hit play. Before we start with the page, I wanted to go over just some new vocabulary that we learned last week. So one thing that we talked about were polygons, and polygons are flat, closed shapes made of line segments that do not cross each other. So, for example, that's a polygon. That's a polygon, but a shape like this, it's not, because that is curved. This is, I tried to draw it straight, but those are straight lines and angles, and this is a curved shape, so that's not. And then something that goes like this is also not a polygon. So those are not, but these ones are polygons. And we talked about line segments, and remember, in math, it's a little bit different than in art, but lines are a series of connected points that continue forever, like that. The arrows show that they continue forever. Oh my gosh, that looks very messy. Let me try that again. And a segment is just a piece of that line, or any line, and it has end points, so it doesn't continue forever. Like that. Those are line segments. A ray is kind of like a line and a line segment. It has one end point and then continues forever in one direction. Like that. Sometimes they'll put a dot on the end so it's clear. It's kind of hard to draw a dot with this. And angles are where either two lines, two segments, or two rays, or like one line and one ray, or one segment and one ray, or something like that, where they meet. So there's a segment, there's a segment, and the angle is this part. And we're talking about right angles a lot, so something like this one right here, that's almost a right angle. Let me try again. But when you have that sharp corner that you could put a page, like line your paper up into the corner, that's called a 90-degree angle, or a right angle. If something is fully like this, like, I know it looks like one straight line, but if that were an angle and those were the two line segments that met there, could you guess what that measurement would be? Well, if you draw a line right here, you can imagine this would be 90 and that would be 90. So then this would be 90 plus 90, which is a 180-degree angle. Now, if you didn't get what I just said, don't worry about it, but that's just a little fun fact for you. And then in a circle, or in 4 right angles like this, that whole thing all the way around would be a 360. So sometimes you hear people say, like, on a skateboard they did a 360. That means they spun all the way around and began where they started again. Just a little fun fact for you. And then to go along with that, we also talked about parallel and parallel. Here's a hint. Look at these L's. Yes, it's two lines or line segments that if they were to continue forever, they would never, ever, ever touch. So these ones are parallel, but this and that, these two lines are not, because if this continues, they would meet right here. But these ones could continue forever. Forever and ever and ever, and never, never touch, if I had drawn them perfectly. Now, sometimes when you draw them as a human, your hand is not perfect, and it messes it up a little bit, but that's why we label things, right, when we say those are parallel. Okay, so hopefully this has helped you refresh your memory. Now we're going to go ahead and get started with practicing drawing and identifying things about different quadrilaterals. And that's something else. Quadrilaterals are a type of polygon that remember quad means 4. So quadrilaterals are polygons that are flat, closed shapes made of line segments that do not cross each other, and they have 4 sides. I know in the dirt biking community, you can have a quad that has 4 wheels. You can also think of quarters that has a similar sound. That also means there's 4 quarters in a dollar, or a quarter of something is 1/4. So keep that in mind. That'll help you remember quadrilaterals. So we're going to start off with parallelograms, and this is on page 325. Think about what you know about parallelograms. What makes something a parallelogram? And it has parallel in it. Remember, this side, which is opposite from this side, side A is opposite from side C. If they continued forever, would they touch? And side B, I meant to do that in a different color. Side B, if that continued forever. Side D, if that continued forever, would they ever touch? No. And that's what makes something a parallelogram. Parallelograms have exactly 2 sets of parallel lines. Should maybe capitalize that T, huh? Oops. They have exactly 2 sets of parallel lines. That's what makes it a parallelogram. The opposite sides are parallel. Opposite sides are parallel. And that's why they call it a parallelogram. All right. Now, we're going to draw 3 different parallelograms. So first, I'm just going to make it easy for myself. Try to follow along on the lines on your page. I'm going to continue this one right there, and this one here. Connect those, and connect those. There's one. That one's pretty similar to the sample. I'm going to draw one over here. Like that. And then I'm going to draw this one. I'm trying to draw on these lines. It's pretty hard on my iPad. And you might be thinking, hold your horses, Mrs. Smith. That's a square. You're right, it's a square, but it's also a parallelogram. It's more specifically a square, but it's also a parallelogram. Just how you are specifically whatever your name is. I'm specifically Caroline, but I'm also a human. You know, you can have both. The squares are special parallelograms that also have right angles, but they're still parallelograms. And squares, all their sides are equal length, and some other parallelograms have different length sides. Like this one has way longer sides over here than it did on this side, and that's okay. But a square still counts, so keep that in mind. All right, let's go ahead and move on to the next one. Now we're talking about rectangles. So, you'll notice that just like a parallelogram, because rectangles are still parallelograms, their sides are parallel. They could continue forever and not touch. Right? The opposite sides could. And then I gave you a hint from German. Recht means right in German. And to be a rectangle, all of your angles, remember that's where these line segments are meeting, they all have to be those squared off corners like that. That's what makes something a rectangle. So the opposite sides of a rectangle are parallel. Here, let me start that over. They're also going to be the same length as each other. The pink ones are the same, and the orange ones are the same. And in math, there's a word for that. It's called congruent. Or you could say unequal. And opposite sides are equal. Equal in length. Now, adjacent is the word that describes neighboring sides, so the ones that are touching. So, in green here, this orange line is adjacent to this pink line and this other pink line. This, I'll do purple. This orange, this side right here is adjacent to that one. It's also adjacent to that one. So it's the neighboring ones. This side over here, this side over here is adjacent to this one. And that one, it's the nearby ones. So the adjacent sides don't have to be the equal length. So do not have to be equal length. If they all are equal length, that's what makes it a square too. When they all have the right angles and equal length. There's also, we've talked very briefly about it, rhombuses. They don't have to have right angles, but they have to have all their sides equal. So rectangles, though, they don't need to be equal length. UAL. But they do meet at only right angles. I'm gonna, oops. Do meet, oops, that's met, meet at only 90-degree or right angles. Okay, so let's go ahead and draw that. So I'm gonna draw, oh man. These opposite sides, equal length and parallel, and right angles only. Perfect. They could be long and skinny. They could be fat like this. Good. Just pretend that's straight there. And then I'm going to do now you might be thinking that's a square. It's also a rectangle. A square is the most specific thing. It's a quadrilateral, a polygon, a parallelogram, a rectangle, a rhombus, and a square. Squares are crazy. So, but remember, we want to make sure it's very clear that these are all right angles, so we can be very meticulous and draw in the right angles. Everyone in the math world knows exactly what you mean when you have these little right angles. They're like, yes, that is 90 degrees, even if you drew it kind of wonky. Okay, so those are our rectangles. All right, now we've talked about squares, and rhombuses a little bit already. Hopefully you remember. Rhombuses, all the sides are the same length, but the angles are not the same as each other. The opposite ones are. That just It's a like fun thing, but they have less than right angles, greater than right angles. To be a square, every single one of your angles is 90 degrees, like that, no matter what, and all sides are the same length as each other. And also, they're parallel. Rhombuses also have parallel sides. So, if you know about rhombuses, they are quadrilaterals, parallelograms, rhombuses, and rectangles. Oof, sorry. And then, what do we know about rhombuses? They are quadrilaterals, four-sided shapes. Parallelograms, and all sides are equal length. Okay, so now we're going to draw two different squares and two different rhombuses. So I'll do my squares first. I'm going to do one little one. Come on, buddy. One little one. Boop, boop, boop. And then I'll do one bigger one. And this one, I want you to think about why it's still a square. I know it's a little funky on this corner right here. I'll try to fix it for you. Like that. Right there. Okay. Oh boy. Oh, I accidentally paused it, so I don't know what I said last in the video. But you might be wondering why this is still a square. It still has only right angles. All of the sides are the same length as one another. Sometimes people will call this a diamond, but there's actually no diamonds in math. That's not a math term. This is just a square turned on its side, but it's still totally a square. They're also still rhombuses, but I'm going to do two different rhombuses that aren't squares just to look at those. So I'm going to do here and right there. Those are all the same side, and I'm marking right here because that's the math way to indicate that these are all the same. And then I'll do maybe 1, 2, 3. This is actually going to have to be about here. Oh my gosh. 1, 2, 3. It's not going to be exactly on that line because you're going to learn later, inside a square, probably not for a couple years, inside a square, this diagonal across is just a tiny bit longer than each of those sides. So that's why I brought it in a little bit, because as we're crossing, it's getting a little bit longer. So as long as we mark it, though, then everyone's going to know these are supposed to be congruent, even if I messed it up with my hands. Alright, so we're going to flip over to the next page. We're going to draw quadrilaterals that are not squares, rectangles, or rhombuses. So they can't have sides that are all the same length. They can't only have right angles. And yeah, they can't have sides that are the same length. So quadrilateral is a what? quad. What is quad remind us of? Yes, it's a four-sided polygon. Name all of the quadrilaterals that have at least one pair of parallel sides. We didn't talk about this one. Do you remember what it's called when it only has one, like this one? Sometimes you might recognize it more if you look at it like that. Yes, these are called trapezoids. So trapezoids, they have one. Squares, of course, they have like all the definitions basically. Rectangles. And rhombuses. I think that's all of them. So now we're going to go ahead and draw some non-squares, rectangles, or rhombuses. So basically this is like way more creative because you can, as long as it's four-sided, closed, and doesn't have any curved lines, it's going to be a four-sided, it's a quadrilateral, right? So let's do... And then like, boom, and then boom. There you go. What about, keeps trying to, and then boom, boom. That's a trapezoid, isn't it? Yeah. And then, how about, oh my gosh, don't lose that. Oh my gosh. Okay. Let's do here. Oh, and maybe that one's like a kite. Oh, I said to do 3, but I did 4, and that's okay. Alright, so that's it for today. Now, once you're done with this, you're going to go into Think Central and complete the activity. Yeah, it shouldn't take too long. Alright, bye-bye. See you tomorrow. Hey everyone, I was just watching this back and I realized my first slide, I have no idea what happened. I can't go back and change it, and it's like too late now. But I'm sorry that it looks so wacky with all the text on top of itself. I'll try to do better next time. Bye.